Okay, today we'll be looking at dimensional units. So the dimension of mass is the first letter here, which is M. The dimension for length is L. The dimension for time is T. Now, mass, length, and time are fundamental quantities. That is to say, they are independent quantities. They do not depend on any other quantity for their definition. They are independent quantities. So we have independent quantities or fundamental quantities like mass, length, time, amount of substance, luminous intensity, electric current measured in ampere, and the rest of the fundamental quantities. Then the derived quantities are those quantities that meets the fundamental quantity for their derivation and for their definition. So, for example, if we look at velocity, velocity is displacement divided by time. Displacement divided by time. So the unit of displacement is in meter, and the unit of time is in seconds. So meaning that the dimension, this is the derived unit of velocity. So the dimensional unit of velocity will now be equal to, anywhere we see meter, which is for length, we write L. Anywhere we see seconds, we write time, which is T. This becomes the dimensional unit of velocity, which sometimes you can write it as Lt raised to power minus 1. That is dimensional unit of velocity. So this is what I want you to know. Then if we are looking at acceleration, the dimensional unit for acceleration is change in velocity divided by time, and the unit of acceleration is meter per second square. The unit of acceleration is meter per second square. So anyway, we'll see this meter for which represents the length. We're going to write L. Then seconds, we replace it by writing T, which square there. Or it can be written as Lt raised to power minus 2. This is the dimensional unit of acceleration, and this is the derived unit for acceleration. Derived dimensional unit of acceleration. You see? Now, let us look at the dimensional unit of force. Dimensional unit of force. Force. What is force? Force is mass times acceleration. Force equals mass times acceleration. And the unit of mass is kilogram. The unit of acceleration is meter per second square. So for mass, which is kilogram, we're going to replace it by writing M dimensionally. Then for meter, we're going to replace it by writing L. Then for seconds, we're going to replace by writing T. So this is the derived unit of acceleration, while this is the dimensional unit of acceleration. So this unit too can be written as M L T raised to power minus 2. So whichever way you see it in the textbook or in the classroom, you should know that this is the dimensional unit of acceleration. Force. Dimensional unit of force. So remember, the topic is dimensional unit. So the next one we're going to look at the dimensional unit of work. Dimensional unit of work. Dimensional unit of work. Work is force times distance. So, but force is mass times acceleration. So we are going to now multiply that result by this distance that we have here. Distance. So the unit of mass is kilogram. The unit of acceleration is meter per second square. Then times the unit of distance again is meter. So everything here will give us kilogram, meter times meter, meter square per second square. This becomes the derived unit of work. But dimensionally, the kilogram, this one kilogram, this one for meter, and this one for seconds. So anywhere we see kilogram, we're going to replace it by writing m. Anywhere we see meter, we're going to replace it by writing L raised to power 2 here. Then anywhere we see seconds, we're going to replace it by writing T raised to power 2. Or it can be written as m L square T raised to power minus 2. This becomes the dimensional unit for work. Dimensional unit of work. You see? That's what we are looking at. Dimensional analysis or dimensional units of some physical quantities. Then let us look at the dimensional unit of power. Dimensional unit of, let's say, momentum. Before we look at power, momentum. What is momentum? Momentum is a product of mass and its velocity. Momentum is mass times velocity. So the unit of mass is kilogram, then the unit of velocity is meter per second. So dimensionally, anywhere we see the kilogram, we're going to replace it by m. Anywhere we see meter, we're going to replace it by L. Then anywhere we see seconds, we're going to replace it by writing T. So there are many ways of writing this. This can also be written as m L T raised to power minus 1. So depending on the choice of the examiner or the textbook or the author of the textbook, it can be expressed like this or like this. You see, this is called dimensional analysis. Dimensional analysis. So, next one. Let us look at dimension of pressure. Pressure. What is the dimension for pressure? Pressure is force per unit area equals force divided by area. So, and force can further be written as mass times acceleration, then divided by area, which is measured in meter square. So what do we have here now? The unit of force will be kilogram meter per second square divided by, let's divide there by meter square, which is the unit of area. So how do we handle this now? We're going to have kilogram meter per second square. This, we're going to flip this and multiply here, and flip this one, we're going to have 1 divided by meter square. You see, that's what we have. So we're going to now have kilogram, this cancel this, remaining 1m here, kilogram per meter per second square. That will be the derived unit of pressure, kilogram per meter per second square. So dimensionally, what are we going to have now dimensionally? By changing the kg to m, dimensionally to m, the m for meter to L, then the s for seconds to T. This will become our dimensional unit of pressure. Dimensional unit of pressure. See? That is the dimensional unit of pressure. So you're going to try it. Thanks for watching. You can also find the dimensional unit of power. You try it and drop the answer in the comment section. Dimensional unit of power. What is power? Power is work done over time. Work done over time. That is the formula for power. Power equals work divided by time. So use this to derive the units of power, the dimensional unit of power, and drop the answer in the comment section. Do remember to subscribe. Bye bye.